Using your 10-1 practice worksheet from your packet, let's try a couple more simplifying radical expressions. If you recall, our goal is to find the largest perfect square inside of a radical, whether I have letters or not in there. So let's just take a quick review here. So if I have the square root of 24, let's say I have a squared, b cubed, c to the fifth, I'm trying to take out all the possible perfect squares. Now, if you recall, we're always looking for the largest perfect square in the number, which this is going to be 4 times 6. 4 is the largest perfect square. So I'm going to take the square root of 4, which is 2, which means the 6 is going to stay behind in the radical because he's not a perfect square and he doesn't contain another perfect square. If you recall, we had a shortcut rule that I'm going to take the exponent and divide it by 2. 2 divided by 2 is 1. It divides evenly. So all of these are going to come out, and I only have one of them. You can put the 1 there if it helps, but you don't need to. Here I have an odd exponent, and if you recall, because it's an odd exponent and I'm taking the square root of an expression, that means there's going to be an odd one that's going to stay behind. 3 divided by 2 is 1.5, so 1 is going to come out. But because it's odd, 1 is going to stay behind. And that's because of that 0.5 that we're getting here. We have c raised to the 5th power. He is odd, so I know that there's going to be an odd one behind. 5 divided by 2 goes in 2 times, and I'm going to have that odd one left over. So my simplified expression is 2ab squared root 6bc. Let's try a couple more. So we have the square root of 24, which I just demonstrated. So we have that 4 times that 6. So we have 2 root 6. This is considered simplified. Remember, this is multiplication. Now 108. 108 is a large number, and so you're going to have to pay attention, and you're going to have to work for the largest perfect square that you can find in the expression. All right, and if you recall our list, we had 4 is a perfect square, then we have 9, 16, 25, 36, 49. And so using your calculator, you're looking for the largest one. Now, at most, it won't be more than half of the number. So half of this number is 54. So the largest perfect square is going to be smaller than 54. So that could possibly be 7 squared, which is 49. Okay, it could be 6 squared, which is 36. 5 squared, it can't be 5 squared because 25 is not a factor of 108. So you're looking for something that's a factor of 108. Interestingly enough, 36 is a factor of 108 by 3. So the largest perfect square is 36. Now, we can find other perfect squares. Clearly, if 36 is a factor, then that means 12 is a factor because 12 is a factor of 36. But it's not the largest perfect square, and our goal is to try and find the largest one. Otherwise, we're having to do a lot of extra steps till I work out all of the perfect squares. Square root of 36 is 6. Left over is the root 3. Reminder that I can multiply my radicals together. So when we take that, multiply that together, 7 times 4 is 28, carry the 2. Is a 98. Okay, and so again, we're looking for the largest perfect square in 98. And so what we're going to find is that the largest perfect square, remember, it can't be more than half. And interestingly enough, if I take and divide 98 by 2 because it's even, I find 49, and 49 therefore is the largest perfect square. So 49, square root of 49 is 7 root 2. If you're not sure how to find that, let's just go back and take a quick look at this guy. When we multiplied that together, we had root 7 times, and think about 14. 14 is 7 times 2. And so I have a pair of 2's or a pair of 7's, which is 49. So that gives me my largest perfect square. So you can always look at the individual factors that created this product in the first place by listing them. rather than trying to, figure out when you bring them all together, like, okay, what did I actually get out of all of that? So let me give you another example. So let's say I have root 4 and 28. Well, we know 4 is a perfect square, but let's take a quick look here at 4, and then this is 4 times 7, right? And so we have 16 here. So we're going to have the largest perfect square there. And so we're going to end up with 4 root 7. So I'm taking it out right away rather than taking 2 and then having to do the whole thing again with the 4 and the 7 and taking the 2 out again, okay, and being left with this 4 root 7. So there are a couple ways to do this, but it's trying to be as efficient as possible. We know that we can multiply the outside numbers together, so I have a 12. I have 3 times 18, so we can think about this a couple different ways. Remember, this is 3 times 3 times 6. Okay, so here I've just generated a perfect square of 9. 6 is not a perfect square, so I can take the square root of 9 out, which is 3. And so I have 36 root 6. Okay, he's not a perfect square, so he can't come out. Yes, I could have multiplied these two numbers together to get a 24 and 2, a 54. Okay, 54 does have the factor of 9 and 6 in it. So yes, I could have done it that way too. So there are a couple ways that we can tackle these problems. Reminder of the variables. So we have 2 times 25. 25 is a perfect square and is a factor of 50. Remember, this is odd, so that means there's going to be a guy still left behind. So the square root of 25 is 5. So I'm going to be left with 2 under the radical. Because he's odd, I know there's going to be 1 left behind here. If I divide 5 by 2, that's going to give me a 2.5. The extra's left behind, but that 2, so p squared, comes out. So we have a 56. 56 is 7 times 8. All right, and so we're looking for the largest perfect square. And so we're going to find that it's going to be in the 4. So this is actually 14 times 4. 4 is the largest perfect square. 14 does not have a perfect square in it. I cannot take the square root of 14. Okay, so if I take the square root, we're going to be able to take the 2 out. That 14 is going to be left behind. If I take the square root of m squared, he's even, so they all come out by half. So I have m to the 1. This one's even, n to the 4th, so they're going to come out by half. None are left behind, so half of 4 is 2. 5 is odd, so 1 is going to be left behind, so I'm going to have an o left behind. If I take them out by half, we have o to the 2nd power.